Team, it's Mr. Z, and today we're going to review domain and range. Probably heard these words before, but let's go ahead and take a look. So basically, I want you to understand the difference is that domain deals with the x's, and it's going to be a scan left to right, while the range is going to deal with the y's, and it is a scan bottom to top. So the idea is that the domain is dealing with the x's. Now, what do you do when you don't have a graph to look at? You're going to have to identify the behavior. So sometimes it helps plugging in a couple of values. In this first one, if I let x equals 1, the output will end up being 1 over 1. So the idea is that, hey, it'll be 1 comma 1. If I let x equals -1, it's going to be 1 over -1 cubed, which will be -1. So the idea is that, hey, my outputs will include some positives. It will also include some negatives. I could repeat this for a lot of numbers, and this process will be the same. Now, it might not be the same when x is 2. That's going to be 1 over 8. And likewise, when x is -2, that's going to lead to 1 over -8. Both of these create outputs that can change, negative and positive. So the idea is that negatives work, positives work. So what is the only difference? Well, what about 0? Remember, when 0 is in the denominator, math breaks. So my domain for this first guy is going to go from negative numbers. All negative numbers work to 0. That's what this says. From left to right, all of the negative numbers work up to 0, not including 0 because it has the parenthesis. Then it's going to skip over 0, still not touching, but then include all of the positive numbers from 0 to infinity. The only number that does not work for the x's is 0. My range? Well, let's look. Can I have negative numbers? Yeah, all of my negative numbers are going to work. Can I get an output of 0? AKA, can I plug in a number, x to the third, to get 0? And if you solve this equation, it's going to be 0 times x to the third if I multiply x to the third on both sides. And can I do 0 times a number to be equal to 1? And the answer is no. No number I can plug in for x will produce a 0. So the graph is not going to touch 0, and then it's going to include all the positive numbers. Now, they are the same answer, but they're talking about two different concepts. The domain is from the part about the denominator. It can't be 0. The range comes from this part where there is no input that produces 0. Notice the difference. The output is 0. Input is 0. Let's go ahead and look at our next one. So the same idea, I'm just doing some theory crafting. If you notice, I test a positive and I test a negative. I always like to test the easiest number available. When x is 1, it's going to produce 1 over 1, so 1 over 1. When x is -1, now this is where it gets dicey. 1 over 1. -1 to the 4th power will produce a positive 1. So it's -1, comma 1. If I do this again for 2, it is going to produce 1 over 16. If x is equal to -2, it's going to produce a positive 1 over 16. So let's go ahead and summarize. So my domain, 0 cannot work. If I plug in 0 here, 1 over 0 cannot happen. So the domain of this guy is going to be from all of my negative inputs work. -1 works, -2 will work, -3 will work. It will go all the way to 0. Skipping over 0, it will then go to all the positive numbers. My range, however, this is where you got to do some theory crafting. Do you notice how all of my numbers, my outputs, even the negative ones, produce a positive? There are no negative numbers that are going to produce a positive output or a negative output. So it is going to start at 0 and go to infinity. It does not include 0. The reason it does not include 0 is because if I try to figure out 1 to the x to the 4th, what number produces 0, if I multiply it by both sides, this is not going to happen. There is no number that produces my 0. Notice also, there are no negative outputs. So that is how I'm able to figure out without looking at the graph visually. When you're given a graph, you just do the method I described in the top. Scan it. So I'm going to go ahead and start from the left. And notice how it's going, it's good, it's good, it's good. I'm going scan to left to right. And it goes all the way to 0. It goes from negative infinity for my domain. And it's going to go all the way to 0, but not touch it. Remember, I would use the bracket if it touched 0, but it can't. There's an asymptote there. Then, what happens? Going left to right after 0, it's going to keep going. So it goes from 0 all the way to positive infinity. For the range, however, it's from bottom to top. So I start from the bottom. It goes from negative infinity, and it's going to go all the way to 0. However, after 0, going from bottom to top, it goes all the way to infinity. I wanted to show you how I look at the graph. Remember, domain is a scan left to right. Range is a scan bottom to top. There is also the point that you notice. X to the third is going to always produce a range where the numbers work. X to the 4th is going to always produce a range of this. Notice it goes back to odd versus even. So 1 over x to the 6 will have a range of 0 to infinity. The domain will be 0 or negative infinity to 0, 0 to infinity. The only number that I can't plug in for x is 0. Whenever it's an even number, it is going to produce the range. If I have 1 over x to the 5th, that is going to produce a domain. While the only number I can't plug in is 0, the range, being an odd exponent, it can have negative outputs. If I plug in a negative number, it does not turn into a positive. So I hope this kind of helps and explains how to identify the domain and range from an equation, from a graph, because you're going to have to do either. So that's it for now. I hope this helped. Good luck on your practice. That's it for now. Ciao.